Hello, in today's session we are going to discuss about the IPTV and mobile TV technology, and I am the presenter Suvarna Kadam. So let us start our discussion in today's session about what is IP audio and what is a IP video. Now as we know that whenever we are talking about the internet protocol television, whatever data or whatever signal is there that must be compatible with internet protocol. So the topics of this particular unit are IP audio, IP video, IPTV, mobile television, and then we'll talk about the video transmission in the 3G mobile system. So we'll probably today try to cover what is the IP video and how you're going to convert your normal audio into the internet protocol audio. So if you see here, to understand what is the IP video, first we'll talk about the audio signal, which is in the analog form initially, and then it is converted into IP packets and known as the IP audio. So it includes the steps which are given below. The first one is nothing but the digitization of the audio. As we know that whenever we are talking about the digitization of any signal, it includes, whenever a digitization takes place, it includes say first in the digitization, you are taking the analog video. Okay, so this analog video is sorry, it is audio. So analog audio is converted into the samples. So next process is the sampling process. After sampling, you're quantizing, you're converting that into fixed levels, and then you are encoding that particular thing. So digitization process includes the sampling, quantizing, and the encoding kind of things. Then coding, whatever encoded signal will be there, that will be coded in a appropriate format. Okay, now this is the thing with the digitization of audio, coding of an audio. Then next one is the addressing. So how you're going to address that particular audio signal. So whatever audio signal is there, that must be addressed, or that must be put it. Suppose I have two packets, one and two audio packets, where it should be go, that is nothing but the addressing. Putting the address on that particular IP packet, you can say this is the addressing. Then transferring, now I have an address with it too, where I need to transmit that audio packet. I know now this will be the actual transferring of that data. Next is the receiving of that particular signal. Then decoding, as you have encoded it initially, you need to get the original data back, that's why decoding. Now you whatever decoded output is nothing but you need to convert that into the original audio signal. So if you see here, your IP audio, or the conversion from analog or conversion from your original audio to the IP audio, you need to do all these things: digitization, coding, addressing, transferring, receiving, decoding, and then converting it into the original audio signal. So these are nothing but the steps which involves there in the IP audio. Now you can see here, this is your audio signal, or you can say speech, whatever is the audio signal is given to the microphone. Microphone converts your non-electrical quantity into the electrical one. So whatever signal you get is after microphone. Microphone is nothing but the sensor, I can say, or I can say the transducer, which converts non-electrical quantity into the electrical one. Then this audio signal will be given to the digitize and compression system. So what is my need here? I need to use a minimum bandwidth for the signal, and that's why if you are considering the internet protocol, there will be the restrictions on the bandwidth, and that's why compression comes into the existence. Analog signal, analog audio signal is digitized, then it is compressed. Then the timestamp process. Timestamp process is a very important process, whereas I need to understand when that packet is generated. 1, 2, 3, 4, 5, 6, these are nothing but the time stamping. Now while transmitting that particular packet, I don't know which route that packet is going to follow and how that order will be there, reception order will be there. It may happen that my second packet get received first and first get received later, because of that particular path which it follows. So I needed to timestamp that particular packet. So it's very important. Then IP address allocation, so where I need to put, or where I need to transmit my first packet, second packet, third packet. Now this is actual a packet switching network, which is, you can say, the interconnected through the routers. So you can say the routers are interconnected. Now you're having a several routers there. So as I have already explained, I don't know which data my which packet will follow. That's why I need to timestamp that particular process. Now IP receiver section, now I have put in my packet on this packet switching network. My packets are going to find out the shortest path to go to the receiver section, then it will be received to the receiver section. Now here this receive our IP receiver section receives only that packet and it is given to the time sequence process. Now this time sequence process will actually ensure that whatever sequencing of packet while transmitting must be same while receiving. So this will be, though you have received your packet 5 first and packet say third later, it will put packet third first and packet 5 later, like that. Now next one is the audio converter section. Now here this audio converter section will convert your audio into the original audio signal, and we know that to reproduce my audio signal I need to give it to the speaker. So here you can see the loudspeaker. So this is the typical IP audio system, whereas I have converted my original audio signal into the IP audio. ठीक है? Now what happens when IP audio transmission takes place? So this complete gives you the idea about the IP audio transmission system. So audio signal digitization we have seen, then compression takes place, then you can say the timestamp is applied, IP addressing is done where I want to send that packet, that addressing or that address is attached with that packet, then IP packet is transmitted on the packet switching network like internet. Okay, so this is the process. Then audio recording. Now here in between we must understand what how the recording takes place. So we are having here the system, say monaural system. So mono audio is only a single speaker. Then stereo, you are having two speakers or two channels, I can say. So if you see here, you are having a left and right channels. 2.1 stereo with a 1 LFE. LFE stands for low frequency enhancement. So you are having a dedicated speaker or dedicated mic. If it is at the recording side, you will have three mics, two main mics, you will put them left, right, and one will be for the low frequency processing. So this is called as a dedicated mic at the recording side and a dedicated speaker at the, you can say, receiver side you are going to apply. 3.1 ProLogic is a surround sound system that adds an additional channel for central speaker in the front. So if you in the 2.1 left, right, and you can say LFE, in 3.1 there will be the left, right, center and one low frequency effect speaker. This is all we are talking about the at the reproduction side, at when you are going to listen that particular audio. 5.1, it's a surround sound system. You are having left, right, center, rear left, rear right, and one low frequency effect speaker. 7.1 is surround sound system, whereas you'll have a left, right, center, rear left, rear right, top, bottom, and one low frequency. So you can see left, right, left, rear right, these are the four. Center, this will be the 5. Here two more speakers get added, that is top and bottom. So at the recording site you just replace speaker with the mics, because whatever recording or what type of recording, अगर आपने left में जो mic रखा है और right में जो mic रखा, if you are putting that left mic there and left mic का output left speaker को ही जाना चाहिए at the reproduction side. So you can say surround sound system is a reproduction of audio signal that surrounds the listener with the sound that is provided from multiple loudspeaker locations. So this is something is about the audio recording. Now how audio signal processing takes place. Now initially when you are giving your signal to the mic, that particular signal we have a sharp changes or high frequencies over there. Okay, to have a sampling or to convert it into the digital format, we need to sample. And what is the criteria for sampling? I know that my criteria for sampling, my sampling frequency must be greater than or equal to twice of FM. So whereas FM is nothing but the maximum frequency component in my signal. Suppose there is a very high frequency noise. Now my audio signal range, as you have already studied, that is 20 hertz to 20 kilohertz. Suppose I am having a 80 kilohertz ka noise spike in my signal, so I need to keep my sampling frequency greater than or equal to 160 kilohertz, which is actually not possible, which will be difficult. So putting it to the sampler or before sampling, we need to remove whatever high frequencies are there. And we know that this is nothing but the audible range. Actually the frequency is more than 15, or in actual if we see that near about 12 kilohertz के above ही आपको वो सुनाई देना बंद हो जाता है. ठीक है. So if these frequencies are not audible, why to keep that frequencies there? So you are having a here audio filter section which is given to the, like you are just filtering out, you are just removing the high frequencies from that, and then output signal with the sharp changes gets reduced. So it will be helpful for you to set the sampling frequency lower in this case. Okay. Next one is the pre-emphasis and a de-emphasis. Now whenever it comes to the, you can say, the frequency modulation, we have heard this term pre-emphasis. So pre-emphasis is nothing but you are artificially boosting your low frequency signals over here. Okay. So you can see you are having, say, you are having a mic is given to the filter, whereas actual audible range like 300 to 3300 hertz, you have just taken care of the speech signal over here. As I can see, as we know, the majority of speech signal lies in this particular range, and we give a 3 kilohertz ka bandwidth for audio signal, for a speech signal. So that speech signal, you have removed the high frequencies from here, then it is given to the pre-emphasis section. So what normally you are having, that your high frequency signal will have a, suppose this is the gain and this is the frequency, आपका जैसे जैसे frequency बढ़ता है आपका gain बढ़ते जाता है. So for low frequency signal you will face the problem, and that's why the low frequency signals are artificially boosted, and that is what we called as the pre-emphasis. Now what you have done, you have increased the gain of a lower frequency, so at the receiver side you must de-emphasize that signal to get the original signal back. So अगर आपने artificially boost किया है तो इसको attenuate भी करना पड़ेगा. Then you have given the de-emphasized signal to the amplifier section, which will boost your signal, which will amplify your signal, and given to the loudspeaker. So these are the processes which we are doing with our audio signal. Now compounding and expanding of audio signal. So compression and expansion. Now you can see here this compounding is nothing but a compression. Now don't take this particular compression term otherwise. If you talk about the compression, so compression is something like this. अगर आपका signal यहाँ पे है, ठीक है, so you are increasing the amplitude of that signal with certain rules and regulations that you might have studied in digital communication, A-law compounding, mu-law compounding. So the signal seems to be compressed, that actually you're not dealing with the frequency in this case, you're just increasing the, or you are just increasing the amplitude of that signal. Okay. So you have just filtered your signal, then what you have done in the compression, you have just artificially boost. So compression takes place, and expansion at the receiver side, you have taken the original signal back. Okay. So this is something you can use here amplifier also, but amplifier will provide the same gain for each and every amplitude or each and every signal. So with the certain rules and regulations, if you are boosting that signal, it comes under the compression and expansion. So collectively that particular term is called as the compounding. Okay. So the next one is how you're going to reduce the noise. Noise reduction, that is dither, is a random signal that is added to analog signal during the digitization process to reduce the effect of quantization noise that occurs at the low level. So this dither is nothing but the white noise. Audio digitization is done using the pulse code modulation. Digital compounding, we have seen how that compression and expansion takes place. Audio format conversion. So what you are doing here, audio conversion, we know that MP3 gives you the maximum compression, then you are converting, your audio conversion is done, that is audio signal of one format, say MP3, is changed to another audio file, that is format AFF. This is also known as the transcoding, and the last step is done with that particular audio is nothing but the audio compression. Okay, so this is how the digitization process takes place. As we have seen, the sampling is done, so this is the sample value, then you are approximating it to the nearest quantization level, that is 1.5. now 1.5, see here actually 1.5 पे आ रहा है, तो अगर आप यहाँ पे देखेंगे आपका जो normalized error है यहाँ पे, that is 0.15. code number for this one is nothing but the 5. It's not exactly 1.5, थोड़ा सा नीचे है, that's why your error is 0.15. ठीक है. Now code number is 5, so now you know binary representation of 5 is 101. So the coding of this particular sample or coding of this particular level is 101. ठीक है. Now next sample is again approximated and it's 3.5. ठीक है. 3.5 का 7, so 7 का code है 111. So this is nothing but how that particular encoding takes place. Audio compression, there are three ways to compress the audio signal: waveform coding, perceptual coding and the voice coding. ठीक है. So whenever we are dealing with the compression is what you are doing here. You are just compressing. I can't say the compression is something which you are like, suppose you are having say 20 kilohertz of a bandwidth, so you are just compressing that bandwidth say up to 2 kilohertz. ठीक है. So this is what we need or what we mean by the compression, because we are dealing here with the bandwidth. Then the lower bandwidths are welcome when it comes to the internet protocol audio. Now there are two techniques of audio compression. The first technique is a lossless technique. So lossless compression means that as the file size is compressed, the picture quality remains the same. It does not get worse. So also the file can be decompressed to its original quality. Lossy compression most commonly used to compressed multimedia data, either audio, video, and images. Now, especially in the applications such as streaming media and internet telephony, where you need a very less bandwidth or where the less bandwidth is the requirement, you can go for the lossy compression. By contrast, lossless compression is typically required for text and data files such as bank records and text article. So this is the difference here. Now what is the perceptual coding? See, here you can see this is your speech signal converted into the signal. So you can see this is the loud signal. So soft signal can't hear directly after. ये loud signal के बाद ये आपका soft signal आ गया. इसका amplitude ज़्यादा है तो ये loud है, इसका amplitude कम है तो ये soft है. अगर loud के बाद immediately soft आता है, you can't hear that soft signal. Now here you can see multiple frequencies signal. You are having a multiple frequencies, not a single frequency signal. ठीक है. Now you are having a small changes in the signal which cannot be here. ठीक है. So signals that can only hear loudest frequency. ये यहाँ पे जो signals है वो सिर्फ loudest frequency पे आप सुन सकते हो. तो in that case what you are doing this, see, if the loud signal and after that you are not able to hear this one, you just remove that one. Signal that can only hear a loudest frequency, keep that only. Remove that small changes which cannot be heard or audible. ठीक है. Now this is the voice coding, digital speech compression using voice coding. आप यहाँ पे क्या कर रहे हो? Actually if you are talking about hello, HELLO, when you say hey, so this is HEH, low, LEL and OH. So instead of putting like biggest, if you see for H you are having a long code word, for U again a long code word, L again a long code word. So you have analyzed how much code word is there. Okay, the lengthy code word is converted into the smaller codes. Like you are having a code book output and the same code book will be maintained at the receiver side also. So this longer code word is reduced in the smaller code word. So you can see you're using a digital speech compression using a voice coding. You just check that voice, you just go for hey. So anywhere if you are having an audio signal anywhere in between and it pronounces hey, the smaller code word will be generated for that hey. L, so like lel, so for lel another small code word. So in this case you are reducing the number of bits. If you are reducing the number of bits, your bit rate will be reduced and indirectly your bandwidth requirement will also be reduced. ठीक है. So we have already seen, this is the mic which will convert your non-electrical signal into the electrical one. This will be the analog to digital converter. Now I have the actual codes for my signal. This is the digital signal analytical section where I'll have a code book for this long. अगर ये code कहीं पे भी appear होता है, out will be 0 1 0. So you can count 1 2 3 4 5 6 7 8 9 10 11 12. 12 का जो आपका code था अभी 3 में convert हो गया. So obviously whatever you will get is nothing but the compressed digital output. ठीक है. Now voice coding systems may operate at the constant bitrate or variable bitrate. Now suppose I'm talking about like how are you, and in between there is a pause. So if I have a pause, I'm not going to transmit any information, or I'm going to not talk about any informative kind of transmission. So why to encode my pause with the same number of bits like as I'm using for how, as I'm using for RNMs. So in the variable bitrate, I'm just checking where are the pauses which doesn't contain any information that will be transmitted with the lower bitrate. Now you can see how it is 9600 bits per second. Whenever there is a pause, I'm transmitting that pause with a lower bit, let's say to 2400 bits per second. So this is a variable bitrate, and in the constant bitrate, the bitrate is a lower and you can say it's constant for pauses or constant for voice also. Okay, so it's a 3.8 kilobits per second. So unnecessarily wastage of this particular thing will be there. So here, if my audio signal is transmitted with a higher bit rate, my clarity of that audio will be very nice, like that. So these are the two options: constant bit rate and a variable bit rate. So this is the typical TCP/IP and multimedia protocol stack. As you have already aware, there is a OSI, ISO OSI reference model and TCP/IP model. So you can see physical link, data link layer, network, transport, session, presentation, application, and in TCP/IP that are just two layers are merged together in the internet network interface layer, internet layer, host to host transport layer, and the application layer. And these are the protocols which governs that particular communication in that particular layers. Okay, in that models. So I am not going to waste my time in explaining all these things because you have already covered this in your uh, computer networks. Okay, so physical layer, link layer, internet protocol layer, then you are having these two protocols, transmission control protocol and user datagram protocol. So this is a typical multimedia protocol stack. Okay, so 1 2 3 4 5 6 7 layers are there, and this is the protocols which is governed by this way. So IP packet transmission, how that particular packet transmission takes place. Now every packet will have a destination network, outgoing interface. अगर आपको destination 1 पे जाना है तो आपका outgoing interface होगा E0, अगर आपको 2 पे जाना है तो आपका होगा TOO ये पे. So this router will have a routing table and it will maintain the information. अगर यहाँ पे मुझे डालना है या फिर ये नेटवर्क पे डालना है तो कौन सा वाला इंटरफेस यूज करेंगे. ठीक है, सो दिस इज आईपी पैकेट ट्रांसमिशन. The next one is nothing but the TCP communication message. So transfer जो network layer में होता है, which actually responsible for the transmission when you put that packet in the network, how that routing kind of things takes place will be governed by this transmission control protocols. So if you see, this is the client and this is the server. So first the synchronization message will be sent to the server. Server acknowledges that synchronization message. ठीक है, यहाँ पे acknowledgement हो गया. Now that acknowledgement will be received by this client and it will again send that I have received your acknowledgement. Now server and client, they will both agreed on the communication. So both acknowledgement message are received. Now the communication takes place because both the acknowledgement message have received, the communication takes place from client to server. Then my client will request for finish communication. My server will acknowledge that. ठीक है, as acknowledgement is received, acknowledgement for what, for finish. ठीक है, तो यहाँ पे finish का acknowledgement मिल गया इसको. उसके बाद ही client also gives the return back message that I have acknowledged your finished message, and the communication in such a way that initiation of communication and the you can say ending of that particular communication takes place. Now the next one is nothing but the TCP packet transmission. So the transmission control protocol packet transmission में आपका क्या होता है? See, here you are having 1, 2, 3, 4, 5, 6, 7, 8 packets, right? And you are transmitting that particular packets. So whenever that packet goes here, यहाँ से, so you can say 1, 2, 3, 4, 5, 6, 7 packet, or you can say where is it? Okay, fine. Packet 4 lost. What happened here? The packet 4 gets lost. So this packet 4 will be retransmitted. So retransmit missing packet. So you can say this is the two-way communication. After receiving each packet, this particular acknowledgement will be sent. And if there is no acknowledgement, this means that that packet is not received and need to retransmit that packet. So this is the two-way confirm. So in the TCP, whenever there is a packet loss, the retransmission takes place. So I can say this is the reliable communication. UDP, that is user datagram protocol. What happens here? Suppose you're transmitting these packets, 1, 2, 3, 4 packet is missing. What happened? Packet 4 lost is a permanent. There is no transmission, right? So in the user datagram protocol, I can say it's unreliable transmission. RTP packet transmission. So real time protocol packet transmission. So here TCP oblique UDP, how that particular transmission takes place. Here you are having talk silent, talk silent, talk. This is the digitization process, this is the timestamp process. Then add address to the TCP header. आपने यहाँ पे address दे दिया है. You have used either TCP or UDP. You have put all that packets on the router, then that packets goes here. ठीक है. So 1 2 4 3 6, as I have told you, I don't know which packet will follow which route. So your packets will not be in order how you have transmitted. So received packets may be of like any order. So I have a resequence of packets, so I have resequenced it, like resequencing is done. Then real time aligning expand processing is there, which will see how the decoding will take place. So talk silence, so whatever data, whatever audio I have transmitted, the same will be received here. Now packet buffering process, buffering, and like if you see here your media server system, here you are having IP packet switching network. Now here buffer memory section. So if the packet is lost, the retransmission request for the lost packet, and that will be given to that particular, say, server, sorry, to the client. Then all that particular packets will be stored first, and you can say buffer memory section, and you can watch it on the IP television with the media player. Okay, so buffer memory section, whereas your packets will be stored and then it will be given to the IP television. So initially, when unless and until that complete process of storing that packets is done, you're not allowed to see all that things. Okay, so till that your IPTV will show you the message, it's buffering. ठीक है, buffering process is storing that thing. Now here audio synchronization process. Now whenever you are talking about the internet protocol television, you are having IP audio, you are having IP video. So you need to synchronize your video and audio. So you are having here a multiplexer section which will combine your audios and videos. Now you are having a program clock reference. So with each and every packet you are having a program clock reference which matches with that particular video stream. So in the multiplexer section, so this is while transmitting that packet, so my audio and my video both are synchronized by using a program clock reference. My audio will have a same clock reference, my video. So for that particular packet, that audio will be played at the receiver side. Audio file downloading, so there are two ways, like either streaming or downloading. Streaming is like you can watch it live, so you don't need to download all the things. Okay, you don't need to store all that packets on your system, and then once it gets downloaded, once it gets stored, you are able to see that. That kind of thing is nothing but the downloading. And when you need to play, you need to download before playing. Okay, now IP audio distortion. So here you can see, as we have seen in the voice coders, you will have a voice code book. ठीक है, यहाँ पे डिजिटल कन्वर्जन होता है, कोडिंग होता है, चैनल कोडिंग होता है. यहाँ पे चैनल कोडिंग सेक्शन में यू आर हैविंग एरर डिटेक्शन, एरर करेक्शन एंड फ्लो कंट्रोल. दैट इज वॉट एवर ट्रांसमिशन एंड receiving flow is there, the data rates must be same. ठीक है, and this is your packet switching network. Now it may happen that your packet gets lost, your packets may corrupted, or your packet may get delayed. So in that case you may find mute kind of things, warble kind of things, and echo kind of things. Okay, so these kind of audio distortions may happen in your audio signal. So this is all about the IP audio. In the next session we'll probably talk about the IP video. So we'll stop here. Thank you.